point 2, graphs of functions. And essentially what happens is to graph a function f, we plot the points x, f of x. So you have a function f of x, and then you choose different values of x, and then you calculate f of x for each of those values, and then the ordered pair, that's what you plot. Okay, so we'll go through the steps here. So for example, here we have f of x equals x squared minus 4, this function here. So so that means that you're going to plot, the first position is going to be x, the original value, and then the second position is going to be what you plug in to get the expression of the function. Okay, so the point 3, so if we let x equal 3, okay, so here, what you do is you calculate f of 3. Okay, so this x here has been replaced with a 3, so we replace that one with a 3 as well. So you get 5. Okay, so that's going to be a 5 right there. And is on the graph. So 3, 5 would be the point that's on the graph. If you want to choose your x coordinate to be 3, then 3, 5 it makes 3, 5 on the graph. The height of the graph above f, above the x-axis when x equals 3 is 5. Okay, and then they have a table here. So let's run through the table. X is -2. F of x is, okay, so let's see, that would be f of -2. You just plug it into here again. So that's -2 quantity squared minus 4, which is 4 minus 4, which is 0. Okay, so that's going to be 0. And that means that the point -2, 0 is going to be on the graph. Okay, then -1. So here you would calculate f of -1. And so that's going to be -1 quantity squared minus 4, which is 1 minus 4, which is -3. So that's -3, which means the point -1, -3 is going to be on the graph. And so on, you continue with each of these. F of 0 is 0 squared minus 4, which is -4. So that means that's -4, and which means that 0, -4 will be on the graph. And f of 1 is 1 squared minus 4, which is -3. So that's that means that 1, -3 will be on the graph. And then this last one, f of 2 is 2 squared minus 4, which is going to be 0. So that's 0, and that means 2, 0 will be on the graph. Okay, so we have a bunch of points there that are going to be on the graph, and then the next problem is to sketch it. So I'll go ahead and put this out right here. So what you want to do is you want to plot each of these points here to get a rough idea of how the graph is going to look like. So I'll start with the first one. So -2, 0. So we come back here to -2, and that will be on the graph. Okay, that's -2, 0 right there. And then -1, -3. There's -1, and then down 3. That's right there. So that's on the graph. 0, -4. That'll be right here. And then these points over here, 1, -3, that'll be right here. And then 2, 0 will also be on the graph. And also we have this, 3, 5 also, which is, I guess we could come over here to 3 and up to 5 and plot that as well. But you kind of get the idea. And so the sketch will be something that goes through all these points. Something like that. And in the questions, it looks like the first graph in the questions will be the answer. Okay, so any questions on that? And that's basically introduction. That's also kind of the introduction of the topic. So graphing functions, you look for ordered pairs of points on the graph and then kind of go through those. Draw a curve that goes through those. Okay, let's look at number 2. So if f of 3 is 15, then, okay, if you plug a 3 in for x and then you get 15, then that means tree 15 is on the graph of f. Okay, and likewise, vice versa, if 3, 6 is on the graph, then f of 3 is equal to 6. There are a few standard graphs of different functions that you probably that you would need to know. So the first one would be the squaring function of x equals x squared. It's a parabola. It's going to be this number 4. This one right here. The second one would be the cube function. It's going to be this one right here, number 2. Or y equals x cubed, I guess you could say. The square root function is another important function. And that's going to be number 1 here. And then finally, the absolute value function. Which is number 3. Yeah, that's what each of those looks like. Okay, so that's just the introduction to some basic functions. You already know about lines. Those are also important. So you also have, this is a note, you also have linear functions, which are ax plus b. We'll talk about specifically about those later, though. That's actually more like a family of functions. Okay, so here we have, this is more like the very first problem. Sketch the graph by first making a table of values. So what you're going to do here is, for this one, x is -3. So what you're going to do is you're going to calculate g of -3. That means that everywhere here that you see an x, it gets replaced with a -3. And this one is different than the first one in that there's the x appears twice right here. So you got to put a -3 in for each one. Okay, this one gives you 9. This is -6 plus 1, so that's 4. And again, that means that the point -3, 4 is going to be on the graph. Okay, so let's look at the next one, g of -2. Okay, so that's going to be 4 minus 4 plus 1, so that's going to be 1. That's 1, which again, it means -2, 1 is going to be on the graph of the function. And then g of -1, that's -1 quantity squared, plus 2 times -1 plus 1, so that's 1 minus 2 plus 1, that's going to be 0. And then we have g of 0, which will be, when you plug a 0 in for the function, that's going to give you your y-intercept, by the way. Okay, those both go to 0, so that's just 1. And then here, g of 1 is 1 squared plus 2 times 1 plus 1, so that's 1 plus 2 plus 1, which is 4. And then we have g of 2, which is 2 squared plus 2 times 2 plus 1, so that's 4 plus, that's 4, and that's still 1, so that's 9. And then g of 3, that's going to be the biggest number so far. 3 squared plus 2 times 3 plus 1. So that's 27 plus 6 plus 1, which is 34. Okay, now for the graph, what you can do is you can plot some of these points here. These are all positive, so that means I'm going to put the y-axis pretty low because I don't need to go negative on the y-axis. Okay, so negative 3, 4. So there's negative 3, and there's 4. And I don't know what happened there. So we got that point there, negative 3, 4 right there. And then, what's that doing? And then negative 2, 1. That's right there. And then we have negative 1, 0, which is right there. Okay, and then we had 0, 1, which is right here, and 1, 4, which is all the way up here. And then we have 2, 9, which is, I guess 9 would be up here somewhere. Okay, so essentially, again, you have this parabola, a parabola. You don't have to plot all the points because 334 is going to be off the page. Okay, so it's like that one, and the correct answer is the third one, the third graph is going to be the correct answer. I made a mistake here, by the way. Let me correct that really quickly. This one is off. This is 3. This is 3 squared is 9. Okay. I'll apologize for that. So 9 plus 6, that's 15, plus 1, that's 16. So this should be 16 right here. Okay, any questions or comments about any of that? Okay, so we have more of these. Here's the square root function. It's the square root of x minus 1. Okay, so here you have the 1. F of 1, you're going to plug that in. This is square root of 1 minus 1, which is the square root of 0, which is 0. So that's going to be 0, which means that the point 1, 0 is going to be on the graph. And another thing, well, it's probably best to like calculate a few of these before we start doing the graph, because then we know, then you know where you can draw the graph to save space, to utilize your space best. Okay, so here this is a 2, so we're going to put a 2 in there. 2 minus 1 is 1, so that's just 1. And the square root of 1 is 1, so that's what you get there. And this next one is f of 5. And then you get the square root of 5 minus 1, which is the square root of 4, which is 2. And here you get a 10. F of 10 is the square root of 10 minus 1, which is the square root of 9, which is 3. Okay, so anybody notice that? So notice that these numbers don't go, they don't, usually you would expect to see 1, 2, 3 would be the next one, but they jump to 5 and then they jump to 10 and so on. And you probably can guess why they do that. So f of 17 would be the square root of 17 minus 1, which is the square root of 16, or 4. And then this is 5 and 6. Okay, now these ones go 1, 2, 0, 1, 2, 3, 4, 5, 6. Okay. So now we see that these are all positive and these are all positive, and these are bigger than these. So maybe we probably could draw the graph like that, because we're only dealing with things in the first quadrant. So when both x and y are positive, that means you're in the first quadrant over here, as opposed to being over here or down there or down there. Okay, what is the second quadrant, third quadrant, fourth quadrant? This is the first quadrant, and everything is in there. So 1, 0, there we go, 1, 0. 2, 1 would be right there, if that's 1. Okay, then we have 5, 2. So let's see, 3, 4, 5. 5, 2. Right there. So that point, and then that point. And then we have 10, 3. So I'll come out to 10. And that goes up to 3 now. And then 17, 4. Okay, maybe 17 is there. 4 is up here. Maybe 26. That would be maybe over here, or maybe further to the right. I don't know. But anyways, the overall graph is going to look like this. So that's the square root. Remember, the square root function started right here and does this kind of thing. But the square root of x minus 1, it's been shifted to the right. We'll talk more about that later. It's basically take the square root function and shift it to the right by 1, and then have the same shape right there. And this looks like the third answer. Okay, let's move along. If you guys have any questions, please ask right away. Okay, number 7, this is kind of an interesting function. So let's go to g of -5. So you're plugging in -5 in here. It's the absolute value of x. So it's the absolute value of 5 minus -5. Okay, that's when you put a -5 in. Okay, so this becomes, this is 5. And this is a minus a -5, so that's plus 5. So that's 10. If you plug a -2 in, you get absolute value of -2 minus a -2. That's going to be 2 plus 2 are 4. And if you plug in a -1, you get the absolute value of -1 minus a -1. So that's going to be 1 plus 1, or 2. If you plug in 0, everything is 0. Wait, what am I doing? That's 2 right there. Okay, if you plug in a 0, then you get 0 minus 0, right? Okay, here's an interesting thing though. If you plug in 1, you get the absolute value of 1 minus 1. So you get 1 minus 1, which is 0. Okay, so you get 0 again. And then if you plug in 3, you get the absolute value of 3 minus 3, which is going to be 3 minus 3, or 0. Okay, so everything over here, you get everything that's, if you plug in any positive number, then you're going to get that number minus itself, or 0. You're going to get 0. Okay, so these are all positive or 0, so that means we can put the y-axis pretty low. But we have some negative numbers here and positive numbers, so let's just split it around the middle, like that. Okay, I'll go ahead with these ones first. So maybe the green ones first. 0, 0 right there, and then 1, 0, and then 3, 0. Okay, and then we'll go with the blue one. So we have -1, 2. Here's -1, and we'll say that's 2 right there. And then we have negative 2, 4. Actually, I made this one is, I probably should be more consistent with my numberings. Okay, so since this distance from 1 to 1 is there, so I'll say that's negative 1 there. And I will go to negative 2 here, negative 3, negative 4, negative 5. Okay, and then I'll do the same thing here. So 1, 2, so negative 1, 2, right here. And then negative 2, that's going to be up at 4. So 4 is right there. And then negative 5, 10, that's going to be, 10 is going to be up here somewhere. I'll probably up here somewhere. Okay, so that's going to go like that. And then the other part is just going to be along the x-axis. That's interesting. And it looks like the fourth graph works. Okay, the next question is a little bit tricky. We're supposed to graph this function in the following and viewing rectangles. Now, this is one of those problems that's written for handheld graphing calculator. But we have a better technology now. We have the graphing calculator online, okay, or Geogebra. Geogebra is pretty good. We're going to use Geogebra for this one. And so we're supposed to graph it in the following windows. So negative 2, 2 by negative 2, 2. And then this one and this one and this one. And then we're supposed to say which one is most appropriate. Okay, so let me go ahead and I will go to Geogebra. So I got some stuff here, but I'm going to delete everything. You don't need to worry about that. Okay, so I'm going to put in the function, which was x to the third minus 5x minus 4. Okay, so that's the function that I have. And if I zoom out, then it looks like this, right? Okay, now the first one said I want a window that is negative 2 to 2 by negative 2 to 2. So if I was to do, so that means going from negative 2 to 2 here and negative 2 to 2 there. Okay, so I really can't, unfortunately, I can't get Geogebra to give me exactly that window, but this is roughly what it would look like. So negative 2 to 2, and then negative 2 to 2. Okay, right there. So this would be roughly what I would see, except I wouldn't see this part over here. See, I wouldn't see that part there. I would just see this right there, boom, like that. Okay, and so as it is, the correct answer on your homework is for the first one is the fourth graph. Okay, and so it's just this part of the graph. It looks like a parabola facing down. That's all. That's all. Just a parabola facing down. That's negative 2, but the 2 by, again, on the x's it's negative 2 to 2. On the y's it's negative 2 to 2. Okay, and so I would say that's not a very good picture of the whole thing, because if we zoom out a little bit, then we can see the whole thing, right? We can see all that. Okay, now the next candidate that they want us to look at is negative 3 to 3 by negative 10 to 10. Okay, so negative 3 is right there, around there. 3 is over here. So from negative 3 to 3, and then from negative 10, there's negative 10 down here, all the way up to 10. Okay, so from negative 3, so it'd be roughly this window here. In fact, I could probably, no, I wouldn't be able to see it. I could probably do like a snippet and just go from negative 3 to 3, and then up from negative 10 to 10. Okay, and that would be what you would see. Okay, so on the homework, it would look like the first graph. Okay, so the second part B, would be the first graph would be the answer on your homework. Okay, now if you think about it though, okay, so this window from negative 3 to 3, and then going from negative 10 to 10, it captures the most important parts of the graph. Okay, although if this was to if instead of going from negative 10 to 10, we went from negative 10 to a smaller number, you would still capture the most essential parts, which would be coming up like that, making this curve here, coming down, curving there, and going back up. Okay, that's probably like from here, from like about right there on the graph all the way to there. That's probably the most important part of it. That's giving you the most important aspects, because above here, it's just going straight up, and it's just going up at a pretty steep rate. And right there, beyond here from here to the left, it's just going down at a steep rate. And that's it. That's all it does. Okay, part C, it says go from negative 3 to 3, and then negative 10 to 5. Okay, so that's still from negative 3 to 3, but then it's from negative 10 just up to 5. Okay, and so you're cutting, and so instead of going from negative 10 to 10 like the last one, you're just going to 5, and so you're cutting out this part right here, which is really not that interesting. Okay, so you're actually making it better by making it smaller. So that one's probably is the best one so far, and that one is going to be the first graph on the answers. That's what the first graph is going to look like. Now, if you're looking at Webassign, you're comparing it with the graphing calculator here, you can see this is really steep, and Webassign is more wide, and that's because of the distortion. From going from negative 3 to 3, that's only a distance of 6. Going from negative 10 to 5, that's a distance of 15. So if you fit it to that window, then you're going to widen the graph quite a bit. Okay, and then the last one is going from negative 10 to 10, and then from negative 10 to 10. So the last one was actually going to look pretty close to this. So we're going from negative 10 to 10 on the axis, and then we're going from negative 10 to 10 on the y. And so you're looking at this square right here is what you're is what you would see, and that it's going to be the first one. Okay, so the first graph on Webassign. Okay, and then that was it. And so we determined that the third graph, I think, was the best because it shows the best characteristics. So let me go back to here. And the most appropriate one, it was the negative 3 to 3 by negative 10 to 5. That's probably the most appropriate one. And then this was the fourth one. This is the first, and this is the first, and this is the first. Okay. I hope that was a good enough explanation for that. Okay, let's go to number 9. Again, if you have any questions, just ask. And here we have sketching a piecewise defined function. So what you can do for this, you can split it up into two different parts. Okay, and the first one would be this first line right here. So y equals 1 minus x would be the first graph that you want to consider. But that's the same as y equals negative x plus 1. So if I put the x term first, then I have it in the standard slope-intercept form of a line. Okay, so this is telling me that the slope is negative 1, and the y-intercept is 1. Okay, so let me go ahead and so if I draw a graph with the y-intercept at 1, and then the slope is negative 1, so it's going to go down like that. Okay, and then it's going to come up like that as you go to the left, like that. I could go further, I guess. Okay, so but then what you do is you say, okay, hold on, this is if x is less than negative 4. Okay, so if we come back here to negative 4, and then we go up to the graph, what I'm going to do is I'm going to put a hole there, and then I'm going to erase all of this going to the right. Like that. Okay. Fill that back in. Okay, and so the first one is going to be just that. Okay. Now for the second one, it's like graphing y equals 3. So here we go, 1, 2, 3. And it's going to be a horizontal line like this. Y equals 3 is a horizontal line. But it's only for x is greater than or equal to negative 4. So that means that I come back here and I eliminate everything that's over here. Because I only want things, x values that are greater than or equal to negative 4. Okay, so that's what it's going to look like roughly. I think I kind of messed up. I think this probably should have been lower because I guess maybe it is right, because that should be like 5 right there. When I put a negative 4 in here, I get 5. Yeah, okay, maybe that works. And the third graph is going to work. Is going to be the most accurate one. On your homework assignment, the third graph is what looks most like this. I think I drew this a little bit too steep. Okay, great. Let's look at number 10. So here they're giving us a piecewise defined function, okay? And so you have this coming in like that. You have this horizontal line coming in right here, but ends right there. And then you have this line right here, which goes from here to here. And then you have a third horizontal line, which goes from here on over. Okay, so let's take a look at, so if we look over here, they've got 3 different expressions, one for each of these. So if you look at the first one, that's when x is less than or equal to negative 1. So here we have negative 1. That's actually going to be all of this. Now, if we extend this all the way out, then that is y equals 2 would be the equation for this graph if you were to keep on extending it all everywhere. So that means if we just put a 2 there, then that will cover the first part. Okay, now the second part is from negative 1 to 2. And that's going to be this piece. This is a line segment. It's half open or half closed, because this is open, that's closed. It includes that point, but it doesn't include that point. But that's because, you know, you have greater than right here, and then you have less than or equal to right here. This is less than, and this is less than or equal to. So that means this is, the point is included, that's not. Okay, so you look and think, okay, what is the equation of that? Well, the y-intercept is 2. And the slope, let's see, if we go from here to here, for example, it's going down 1 and over 1. So that's going down 1 and to the right by 1. So that's going to be -1. Okay, and so that means that the equation of the equation of the line that contains that segment is -x, because the slope is -1, plus 2. Okay, so you can put -x plus 2, or if you want, you can put 2 minus x also works. And then this last piece, x for x greater than 2, that's this one. And that's just going to be y equals -1. So -1 would be what works there. Okay, moving along to number 11. In order for the graph to represent a function, it needs to satisfy what we call the vertical line test. And that means no vertical line can intersect it in more than one place. And since no vertical line intercepts it in more than one place, this one does work. It is a function. This one also is a function, because no vertical line intersects in more than one spot. Okay. Here are examples that are not functions. So this is not a function. That's not a function either. It's because if you draw a vertical line right there, it intersects in more than one spot. Okay, so let's say for example that this value were 2. Okay, so then you would have a dilemma trying to figure out what f of 2 is. Okay, if this were 2 right here. Because you got a point on the graph there, you got a point on the graph there, you got a point there, and a point there. So what is f of 2? Okay, it can't be all those 4 points. Okay, and be a kind of a function that we're used to having. The same thing here, intersects in more than one place. Okay, so let's say that were 1. Okay, what would f of 1 be? There's 3 different candidates. But you have to be clear. It has to be clear. There has to be a clear one that it is. Okay, so that's why those are not functions. Okay, number 12. Again, here this is not going to be a function. So it's not a function because it doesn't it violates the vertical line test. Okay, so here, like at -2. Okay, what's f of -2? No, that's 2 possible values that it could be. Or f of 0, what that would be? Is it 2 or -2? You have to just have it being 1 value. Okay, and so then here, if the curve is not a function or not, okay, so we can just enter none there. Now, though those are technically the correct answers, but one could argue that it doesn't define a function, but it defines a relation between x and y. And in that relation, the domain goes from -5 to 5, and the range goes from -2 to 2. Okay, so the domain goes from -5 to 5, and the range goes from -2 to 2. So one could argue that, but they don't want us to do that. They want to just give us the easy way out there. Okay, now from an expression, determine whether this expression defines y as a function of x. Okay, so if you can solve it for y, then it's generally going to define a function of x. So like, for example, I can take this 3x squared over to the side as a negative 3x squared. And then I can divide by -1, and I have y equals 3x squared minus 5. Okay, now I can put in any value that I want for x, and any value that I put in for x that works here, it's just going to give me one value for y back. Okay, so that means that the answer is yes. And the second, on the other hand, number 14, again, I can try to do the same thing. This 2x goes over, x squared goes over as negative 2x squared. Then I can divide by -4. I get something like that. Okay, now, if I go one more step, then I'm going to be giving this plus or minus thing here. And this plus or minus creates problems because if I make x equal to, let's say, 4, for example, then I'm going to get 2 values for y. Okay, so x equals 4 gives 2 values for y. Okay, and that's a problem. So that means that no,